Number 13. We have f of x equals 3x cubed on the interval from 1 to 1 plus h. So f of x2 minus, well, let me write f of x first. F of x equals 3x cubed on the interval 1 to 1 plus h. Now we have f of x2 minus f of x1 all over x2 minus x1 equals. Alright, so you put x2, which is 1 plus h, into the x in the formula for f of x2. So you got 3 times 1 plus h cubed, quantity cubed, minus f of x1. So that's f of x1 is 1. So minus 3 times 1 cubed. All over x2 minus x1, 1 plus h minus 1. Alright, let me go over here. I think I'm going to need some space. Now, again, according to order of operations, you evaluate the powers first, and then you can multiply the 3. So you don't go multiply the 3 in there, 3 plus 3h, and then cube that. Okay, that would be incorrect. So you have to expand this first. By expand, I mean evaluate that power. You know, it's going to expand when you do that. So if you don't know what that is, there are formulas for this that you can look up. But you can do it yourself. So let's do that. So this is equal to 1 plus h times 1 plus h squared. That would multiply together, that would be 1 plus h quantity cubed. Alright, and then this is 1 cubed, which is 1. So all that is minus 3 there. And this is h down at the bottom. The 1's go away, 1 minus 1. Alright. So we have 3, parentheses 1 plus h. And this is a binomial squared. A plus b squared is a squared plus 2ab plus b squared, right? So a squared would be, a would be 1 and the b would be the h, right? So you got a squared, that's 1 squared, which is 1, plus 2ab, 2 times 1 times h, which is just 2h, plus b squared or plus h squared. So 1 plus 2h plus h squared minus 3 all over the h. And you might notice you could factor a 3 out on top. You know, there's nothing that you can cancel with down below, so just leave it alone for now. Maybe we could see something later. And then we've got 3. Now you can use the distributive property on this. Think of this as one object, and you're multiplying each of these terms inside the parentheses with this one thing. Alright? So that's using the distributive property. So let me put this in brackets. You got the 3 multiplying all of that, so I don't want to lose track of that. So now you've got 1 plus h times 1, or just 1 plus h. I'll just write the 1 plus h. And then plus 1 plus h times 2h. Let me write that out. And then plus, as you can see there, 1 plus h times h squared. End bracket, and then minus 3 at the end, all over h. Alright, so you see what we did? Distributed the 1 plus h as one thing through this trinomial. So this times 1 is that, this times 2h is this, and this times h squared is that. Okay? Now all you have to do is in the brackets multiply everything out and then simplify. Alright? So it takes a little time, but what are you going to do, huh? Alright, so you got 1 plus h plus, now distribute the 2h through. That's 2h times 1 is 2h, so that's positive 2h. And 2h times h is 2h squared, so that's plus, from that plus there, 2h squared. Alright, now, plus h squared, distribute that through. H squared times 1 is h squared. H squared times h is h cubed, so that's plus an h cubed. And I could have used parentheses here, but I'll just keep using the brackets because that's what I started with. Alright, now we need to combine like terms if we can. Well, all I can see here is the 2h plus the h. Alright, so we've got 3. I'll use parentheses now. And we've got the 1 plus 2h plus h is 3h. Let's see. Oh yeah, we've got this too. 2h squared plus h squared is 3h squared. And then plus h cubed minus 3 all over h. Okay, so now distribute the 3 through. I'm going to continue it, let's see, over here, so I don't have to erase anything. These pens constantly start to get dry. It's not like the good old chalk, but I don't have chalk dust at least. And this is fluorescent. Alright, so distribute the 3 through. 3 times 1 is 3. Let me write this a little bit small. 3 times 3h is plus 9h here. The plus comes from that plus there. So that's plus 9h. And then 3 times 3h squared, that's 9h squared, so plus 9h squared. And then 3 times h cubed is 3h cubed, plus 3h cubed. And then you've got the minus 3 at the end, all over h. Alright. Continuing on, 3 minus 3, that's 0. So you've got 9h, well, let me write the h cubes first, just because that's a traditional way of writing it. So we've got the highest power first, 3h cubed plus 9h squared plus 9h. And the 3's are gone, and that's over h. Looks like we can common factor the h. And so let's do that. H parentheses 3h squared. Or rather, I can factor a 3 as well out of there, but since there's nothing to cancel it with in the denominator, I'll just leave that part alone. Alright, we'll leave the 3's. We'll leave the constants as they're written, the coefficients as they're written, and just factor the h, because you'll be able to cancel that with that. Now, so we go, what's that, 3, let's see, h, and then we've got 9h, okay, plus 9h. Oops, forgot the squared there. So we got 3h squared plus 9h plus 9 all over h. And now you can cancel After you've factored, you can cancel. All right. If you cannot factor, you can't cancel. Remember that. Okay, so that leaves you with just 3h squared plus 9h plus 9. And that is it. Okay, problem number 15. We want to evaluate this expression. This is called the difference quotient. Okay, why are you doing this? Because you'll need the practice when you go into calculus. This is pre-calculus, after all. And anyway, if you do go into calculus, you'll be doing a lot of these. All right. It's involved in the definition of a derivative. A derivative is basically the first half of calculus 1. All right. So you'll be doing several of these at least when you take the course. So you're getting a little practice now on how to evaluate these difference quotients. All right. So we have f of x plus h minus f of x all over h. And my board is weeping again. Weeping for you, dear student, when you have to do these in calculus. Alright, well, that's okay. It's part of the course, and you'll learn a lot. Alright, f of x plus h minus f of x all over h. Alright, and that's given that f of x is 2x squared minus 3x. On the interval from x to x plus h. All right. Okay. Now, here we go then. So we have f of x plus h minus f of x all over h is, first of all, you have f of x plus h. Let me bold this out here. F of x plus h is first. All right, what is it? F of x plus h? You plug in x plus h in the x squared and in the x here. All right, so that's 2 x plus h squared minus 3x plus h in parentheses. And then you're subtracting f of x, so subtract minus, and then put some kind of grouping symbol like parentheses and just write f of x. This is minus f of x, 2x squared minus 3x. Alright, and that's all over h. Okay, so this part all here, these two terms here are f of x plus h. And then you're subtracting, and this part right here in the parentheses is f of x. All right? So you got f of x plus h minus f of x over h. All right. So you've got 2, again, order of operations, you expand this, you square it first, and then you multiply the 2. All right, don't go 2x plus 2h and then square it. All right, so you've got 2 parentheses x squared plus 2xh plus h squared. All right, So there's your x plus h quantity squared. And now here, there's no power except for 1 there, so you can just distribute the minus 3 through there. Minus 3x minus 3h. Minus 3x minus 3h. Alright? And then you can distribute that minus sign through, so that's going to be minus 2x squared. And then minus a minus is plus 3x. And that's all over h. Distribute the 2 through now, so you got 2x squared plus 4xh plus 2h squared, and then let's do a little simplifying here. Minus 3x plus 3x is 0, so that leaves us with just the minus 3h minus 2x squared all over, if I can get this thing to write, I'm going to have to get a new pen, all over h. Okay. New pen means a new color, folks, so it'll be like pretty cool. Okay, so you got 2x squared minus 2x squared is 0. Okay, so what else? What do you got? What else can you do? That's about it, huh? 4xh plus 2h squared minus 3h all over h. Okay. Now you can factor the h out of there. You got h in all three terms. So factor that out because you'll be able to cancel it with that one. And then you've got 4x plus 2h minus 3. Minus 3. Okay. Over the h. And the h's cancel. So finally you end up with 4x plus 2h minus 3. X plus 2h minus 3. There you go. Okay, number 17. They give us a graph. Consider the graph of f shown below. And this is in your book. I'll refer you to that because I don't want to copy this. This is figure 15. Estimate the average rate of change from x equals 2 to x equals 5. So in order to do this, you use f of x2 minus f of x1 over x2 minus x1. The only thing you have to do is figure out what f of x2 and f of x1 are. Alright? So let's take a look at this. What are f2 and f5? f of 2 rather and f of 5. That's what we need. Right? Because x1 here would be x equals 2, and x2 would be x equals 5, alright? So we need f of x2 and f of x1. So what's f of 2 and what's f of 5? So you look at the graph. Let's see if I can zoom in here. So f of 2, x equals 2 there. F of 2 is, looks like 3, right? Looks like 3. Alright, so that's 3. What's f of 5? Way up there. Looks like 7. F of 5. Alright, so f of 5 is 7. Okay, so we have f of 5 minus f of 2 over 5 minus 2. That's the formula f of x2 minus f of x1 over x2 minus x1. Okay, so now we know what f of 5 and f of 2 are. That's 7 minus 3. 5 minus 2 is 3. And this is going to be 7 minus 3 is 4 over 3. So the average rate of change is 4/3 from x equals 2 to x equals 5 for this particular function they gave us. Okay, number 19. For the following exercises, use the graph of each function to estimate the intervals on which the function is increasing or decreasing. So let's take a look at this function here in the book. Okay. What do they mean by increasing or decreasing? Notice that it's increasing here. Right? Increasing, increasing, increasing. And then it starts to go down, 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 so it's decreasing right to there. And then it goes up, 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 it's increasing. So what are the intervals on which it's increasing and decreasing? All right. So looks like this keeps going, going to negative infinity. So it's increasing from negative infinity all the way up to that x value there, whatever that is. And then it decreases from that x value to this x value. Looks like x equals 1. And then it goes up to, it increases, right? So it increases to positive infinity. From x equals 1 to positive infinity, it keeps going up, up, up. So if you look at that closely in your book, here's what you should come up with. All right, it's increasing from negative infinity to what I see as negative 2.5, all right, negative 2.5. It's also increasing from 1 to infinity, so you take the union of that with the interval from 1 to infinity. Okay. And it's decreasing between negative 2.5 and 1 on the x-axis there, negative 2.5 and 1. Okay.